Well, hello, good day, everybody. This is Jesse Anang. Welcome to Software Engineering Chapter 3. My name again is J.A. Anand. So let's look at the various things that we need to consider in Lecture 3 of Software Engineering. Objective of study. At the end of the lecture, we'll get to know what is the iterative waterfall model, the prototyping model, the evolutionary model, and then the spiral model, and then the rapid application development. So over here, we want to consider all the other models that may come or under software engineering. That is software developmental life cycle. We have already talked about the classical waterfall model in the lecture 2. That is the chapter 2 of this course. We've already talked about the classical waterfall model. So in this chapter 3, we want to now consider the various models. And I wish that, after this video, my students will go deeper to get a better understanding of these various models that we have explained here. So now let's look at the second aspect, or that is the iterative waterfall model. Or in some books, they used to write the iterative model. To overcome the major shortcomings of the classical waterfall model, we come out with the iterative waterfall model. Here, we provide feedback paths for error corrections as and when detected later in the phase. Though errors are inevitable, but it is desirable to detect them in the same phase in which they occur. If so, this can reduce the error to correct the bug. The advantage of this model is that there is a working model of the system at at a very early stage of development, which makes it easier to find functional or design flaws. So over here, the iterative, just as the word even says, that at every stage there is the need for us to um, find out if there are errors somewhere, work out on the errors, correct them, and then move on to the various stage. Even if we move on to the various stage, we can still come back and then rectify some errors at the already state, or the state that has already been completed. So over here, we can see that the iterative waterfall model is a correction of the flaws of the classical waterfall model. So based on the problems we face in the classical waterfall model, the iterative model comes to correct them. And that is the understanding about it. So this has to do with the various stages that comes with the iterative waterfall model. But before that, let me see. It says finding issues at the early stage of the development of development enables to take corrective measures in a limited budget. The disadvantage the disadvantage with this system developmental lifecycle model is that it is applicable only to large and bulky software development projects. This is because it is hard to break a small software system into further small serviceable increment models. Okay, so that explains that for the iterative model, it is considered for bulky software products. And these are the various stages. We have the requirement, we have the planning from the after the requirement and planning, then we come to the next phase, which is analysis and design. From there, we move on to implementation. And then from implementation, if there is no error detected, if there is nothing to be considered about, then we move on straight to the deployment of the project. And then, or else, if there are issues, then we come to testing. From testing, then we come to evaluation. Then from evaluation, we go back to what? To the planning stage again. We go back to the planning stage again. And then from the planning, we come back to the analysis. From the analysis, we come to implementation. We come to testing. If no further errors or no further issues have been considered, then we move on to the deployment of the product. Now we want to also consider the third model. Okay, so the third model is called the prototyping model. A prototype is a toy representation of the system. A prototype usually exhibits limited functional capabilities, low reliability, and inefficient performance compared to the actual software. A prototype is usually built using several shortcuts. A shortcut may involve using inefficient, inaccurate, or a dummy functions. The shortcut implementation of a function, for example, may reduce the desired results by using a table look instead of performing the actual computation. A prototype of the actual product is preferred in situations such as the user requirements are not complete, technical issues are not clear. So now let me explain this, that at a prototyping model, there is a dummy representation of the actual product that needs to be developed. So then the user of the requirement, or the one that wants the software, will look at the dummy and give a clear idea of what they want the software to accomplish. So if you go for the interview and you go for, let's say, the discussions, or you carry out your surveys and investigations pertaining to the software you are to develop, and you are not clear about what the people are talking about, maybe they are not using the right technical terms, or maybe you are trying to gather the data and you are not clear with it, you can go with a dummy. Once you go with the dummy gives the one who is looking at the toy representation, or who is looking at the sample you have brought, and then it will help them to tell you what they really want to talk about, or what they really need in their product or in their software. So over here, why would we consider a prototype when we are not clear about the requirements that the people are talking about, or when they are technical issues? He's trying to explain something, but he doesn't know the technical term to consider. Then we can go with the prototype. All right, so it says prototype. A prototype usually turns out to be a very crude version of the actual system. It says need for a prototype in software development. There are several uses of a prototype. An important purpose is to illustrate the input data format, the message, the report, and the iterative dialogues to the customer. So once you go with an input concept, a message, a report, and then an iterative of how the actual system would look like, it gives the customer a clear understanding of what you intend to develop for the person. If there is any input or feedbacks the person needs to tell you about, then the person can now say that, okay, based on what you have brought, this is what I want. And then you can now know what to do with that. It says this is a valuable mechanism for gathering better understanding of the customer needs. It says how the screens might look like, how the user interface would behave, how the system would produce outputs, and then the various reports that the system can generate um, for the user. It says another reason for developing a prototype is that it is impossible to get a perfect product in the first attempt. Many researchers and engineers advocate that if you want to develop a good product, you might plan to throw away the first version. So over here, the first version, or any first product at all you come out with, provided you want to go into product development with respect to software, it means that the first version will not be that good. So as you progress, as you build on it, you gain more experience in your work, and you are able to come out with a better, an excellent job done, or maybe a job that can really fit the requirements of your users. The experience gained in developing a prototype can be used to develop the final product. A prototyping model can be used when the technical solutions are unclear to the development team. A developed prototype can help engineers to critically examine the technical issues associated with the product development. Often, major design decisions depend on issues like the response time of the hardware controller, or the efficiency of a certain algorithm, etc. In such circumstances, a prototype may be the best and the only way to resolve technical issues. So once you go with the idea of the prototyping model, I mean, it goes a long way to really get what the customer desires for and what the customers want to see. So this is the diagrammatic representation of the prototype model. We have the requirement gathering, we have the quick design. From the quick design, we move on to build the prototype. When we build the prototype, we give the prototype that has been developed to the customer evaluation of the prototype. They consider that if everything is working well and everything is working perfectly, what do? We come to the acceptance by the customer, where we move on to design. From design we come to coding, from coding we come to testing, and we move on to the maintenance. But if something is not clear about the prototype that has been given, then from the building the prototype to the customer evaluation of the prototype, we now move on to the refined requirements, incorporating the customer's suggestion. Then we come to quick design. So once we move from design, build prototype, customer evaluation, and then there are some things that needs to be considered, we go back, do the correction, bring the thing to the that is into the prototype. We go back to the customer evaluates it. Once the customer is satisfied with the corrections we have made in the prototype, we move on to design, and then coding, testing, and maintenance comes into play. So most of the time, I encourage students, even if you are doing your project that has to do with software or a product, what do? It is often considered to use the prototyping model. I mean, maybe you can also use other means by which you can develop the software. Now we move on to the fourth thing that has to do with evaluation, the evolutionary model. Sorry, it says evolutionary model. It says that it is also called the successive version model or the incremental model. It says at first a simple working model is built. Subsequently, it undergoes functional improvement, and we keep on adding new features till the desired system is built. So we can, even in the phone industry, we can talk of the various versions of phones that have been made, and those concept follows the evolutionary method. So we develop a first model of the product, we give to customers, everybody is using it. Within the space of time, we collect feedback from the customers who are using the software, and then once we have gathered or we have collected those feedback, in our next production or in the next release of the same product we want to come out with, we incorporate the suggestions and the response from the customer into the next product. So that is why it is called evolutionary method. So you can talk of iPhone. It came with iPhone 3, iPhone 4, iPhone 5, iPhone 6, and all that. Various successive versions has to come into play just to get the new features and other things that may come with the software. So applications, large projects where you can easily find models of incremental implementation, often used when the customer wants to start using the core features rather than waiting for the full software. Also used in object-oriented software development, because the system can easily partition into units in terms of budgets. And then let's still also look at the advantages and the disadvantages of the evolutionary method. So over here it says that user gets a chance to experience partially developed system, reduce the errors because the core models get tested thoroughly. And then the disadvantage, it is difficult to divide the problem into several versions that would be acceptable to the customer, which may be incrementally implemented and delivered. Now let's look at the diagrammatic representation of the evolutionary method. So we have the software concept, we move on to the preliminary requirement analysis, and then we come to the design of the architecture or and system core. From there we move on to develop a version, Once we develop a version, it goes through a cycle. It goes through a cycle, and then we come out with a what? So it moves to the deliver the version, elicit customers' feedback, incorporate the customer feedback, and then we go back to the what? To develop a version again. After the version has been developed, what do? We deliver the final version. So once we come out with the first version, we give it out, and then we go through the gathering of the various feedbacks that may come with the system, and then at every stage we come out with another release, and then we give it to the customer. And some business people often say that the customer is always not satisfied, so once they start using a particular product, they want a better version of it. So then they might criticize it, they might talk about it, they might talk about some features, some behavioral patterns, or maybe some constraints that the system has come with, and then we can do the various corrections on that. Now let's look at to the fifth methodology that has to do with the spiral model. It says the diagrammatic representation of this model appears like a spiral with many loops. The exact number of loops in the spiral is not fixed. So each loop of the spiral represents a phase of the software process. For example, the innermost loop might be concerned with feasibility study. The next loop would look at the requirement specification. Then the next one might would be design, and so on. Each Each phase of this model is split into four sectors or quadrants in the diagram that is shown below. So now let's consider the diagram. So we have the spiral model, we have the various quadrants or the first. And so now the first quadrant talks about the determination of the objectives, and then we have the alternatives and constraints, and then the second quadrant talks about the risk analysis and the alternative evaluation, and then we come to the third quadrant that talks about the the development of the deliverables, and then we have the next iteration planning. So, and then we at every stage too, we consider what we look at the things that needs to be considered. So in the first quadrant, that is our start, and then from the second quadrant we have the risk analysis that needs to be performed there, and then we also have the prototype. And then from there, we come to the next phase, that is the third quadrant, where we could consider, let's say, the concept of the prototype that has been developed. And then we move on to the requirement plan. Again, we come to the requirement plan, and then we move on to another spiral where we have the risk analysis, we have the prototype too, we have the software requirement, we have evaluation, and then we have the development plan. And that would also lead us into the third quadrant where we have the risk analysis, we have the prototype 3, we have the software design, we have the evaluation and verification, and then we come out with the we move on to the integration and the testing plan, and then we move on to another another spiral that may come with the risk analysis. We have the operational prototype, the design, the code, we have the unit testing, we have the integration and testing, we have the acceptance testing, and then we come with the release. So this explains the spiral model, but this is also another diagram that is talking about the spiral model and all that. So it's either you can draw the first diagram or the second diagram. And most of the time, I encourage my student that if during interview or question time or during exams, and you are asked to explain any of the models, make sure you include the diagram, because the diagram gives also, or it makes the examiner know, what you are really talking about and all that. So that's the spiral model. On the first quadrant, the things to consider. It says during the first quadrant, it is needed to identify the objectives of the phase, and then we also have examined the risks associated with these objectives, and then we move on to the second quadrant, that is the risk assessment and reduction, and then a detailed analysis is carried out for each identified project risk, and then steps are taken to reduce the risk. For example, if there is a risk that the requirements are inappropriate, a prototype system may be developed. And then we come to the third quadrant, that is develop and validate the next level of the product after resolving the identified risk. And then we come to the fourth quadrant where we have the review the results achieved so far with the customer and plan the next iteration around the spiral. We have the progressively more complete versions of the software gets built with each iteration around the what around the spiral. Circumstances to use the spiral model. At what point do we consider to use the spiral methodology of software developmental life cycle? So over here it says that the spiral model is called the meta model since it encompasses all other life cycle model. Risk handling is inherently built into this model. The spiral model is suitable for development of a technically challenging software product that are prone to several kinds of risks. However, this model is much more complex than the other models. That is probably a factor deterring its use in ordinary projects. So now let's come to the various interview questions that we need to consider here. It says that explain with a diagram the various models of software development and life cycle. So you can pick one particular model and then you can explain it, talk about the various steps that needs to be considered, and then include a diagram in your work. The question two says, which of the various model is best for developing a software? So which of the various model is best developed? How would you answer this question? I just want to see, my viewers or my listeners, answers pertaining to some of these questions. Explain the shortcomings of the various models. So pick one model, talk about it, but also explain the shortcomings of the model. And I also want to encourage my students to go out there, get some other books, look at the various advantages and disadvantages of using some of these models that we have explained, and it would also help you during exams time. It's not everything that I'll have the chance to record and even consider. So I just want to encourage you, go out there and make more research, go read more books pertaining to software developmental life cycle, and let's talk about it. Visit my Facebook account, my Instagram, my YouTube channel, and then you can also send me a contact message. My contact is right there, and it's been supported by ProTechAfrica. I encourage anyone who wants to support this initiative. Let's come together. Let's make learning easy and acceptable by all. And God bless us. Thank you very much. And the name is Jesse Anand. Anand. Thanks very much for watching Software Engineering. For more questions, visit the website